you guys did the second multiple choice section for 2008. Here's my solutions for it. I already put them on Facebook and on Edline, but if you want to take a look and see what they were like, you can keep this obviously. It's my solutions. It might help you clarify some of the stuff. So this is the answers to what I just gave you. I gave you the section. That's the answers. Obviously do the section first. I would seriously have like an AP binder or a folder right now, because you're going to get even more and more of these. And unfortunately, we're going to kill a lot of trees in the next 2 weeks. It's okay. For the benefit of the group, yes. It's a great event.
Benefit of mankind.
Mankind, my college student. Karen, Kenny, Karen, Kenny. Are they all the same? Karen's like here, Kenny's on the outside.
Yeah.
Maybe that's true.
Yes, Karen's there.
Karen's
Karen is
Domain.
In the clue.
Alright.
Put her in the back too later.
No. Put her in
Right? Number 89.
Go to this one now, because we're going to talk about this. Other test. Yeah, that's the one that we did for practice.
Guys, so again, what we're doing today is we're going to finish off these last few multiple choice, then go on to the part 2 free response stuff that we looked at for the test. So, number 89 says, let f be a differentiable function where f of 2 equals 3, f prime of 2 equals negative 5, and let g be the function defined by g of x equals x times f of x.
Someone's not getting pizza.
Which of the following is the equation for the line tangent to the graph of g? Okay? Those are the pages that we're missing. They are in there. Oh, those extra missing. Got it, thank you. So, here's what I would think right away. When I see f of 2 equals 3, I say to myself, well, the point 23 is somewhere in there. Agree with that? The point 23 is there. So f of 2 equals 3 tells me that the point 23 is there. Next, g of x is equal to x times f of x. G of x is equal to x times f of x. So, eventually, I'm going to have to find the graph of g. So if I want to know what g of 2 is, it's going to be the x value times f of x. Again, this is x, this is really f of x. So if you want to know what g of 2 is, you have to plug in x, which is 2, times the f of x, which is 3. So g of 2 is now 6, and that helps me a lot. Again, that helps me a lot. The next part that's even tougher is this. To find g's equation, I need g's slope. But to find g's slope, I have to use f's slope. So I need to take the derivative of this function now, right there, to get g prime. And if I look here, x times f of x, isn't that a product? So to find the derivative of g's function, I need to use a product rule. So I think of this as a, I think of this as b. So I do a times the derivative of b, or f prime of x, plus b, which is f of x, times the derivative of a, which is just 1. And if you want to find g prime of 2, you just plug in a 2 here for all these. So 2 goes in for x. What is f prime of 2? Because 1. Thank you, it's given. F prime of 2 is negative 5. So this f prime of x is f prime of 2, which is negative 5. So 2 times f prime of x plus f of x. But what's f of 2, guys? It's 3, it's given. So that's going to be a 3 there, times 1. So the slope of g is negative 7. The slope of g is negative 7. If I know the slope, and I also happen to know a point, where's my point? My point is right here. G of 2 equals 6. If I know that g of 2 equals 6, I go ahead and plug in a 2 in for x, and a 6 in for y, and I solve for b. Now, the problem with this problem is this. That's not a choice, is it? It's not. So instead of using y equals mx plus b, what should we use? Good, which is called point slope. Point slope. Okay, y minus y1 equals m, parentheses, x minus x1. So that's what I did on the next part, I'll show you. I said, since the choices are in point slope form, instead of that, let's use this formula. So we can always use either this formula here, or this formula here. They are identical. Doesn't matter. M is still your slope. There's your slope still. y1 and x1, those are your points. So go ahead, instead of plugging in the 2 and 6 and solving for b, plug in the 2 here, plug in the 6 right here, and you'll see that's exactly what you get. Choice is D. This is not an easy problem. This is one of the toughest ones on the test.
In this case, since -7 was always slope, or -7
Was a slope of g.
Yeah, so would you then only appear once the answers because it just comes straight to you?
Touche. Absolutely. I didn't even look at the choices. Everybody see it? Once you got -7 as a slope, what's your answer? Look at all your choices. It's got to be D. Part A has a slope of 3. B and C have a slope of -5. E has a slope of -10. I agree with Christian completely. I did all the work because I was just doing the solution, but he's right. At this point in time, guys, right here, go back up. When we found out the slope of G was -7, or the slope of the tangent line to G was -7, automatically choose choice D. Absolutely. Good call, Christian. Good call. All right, number 90. Number 90, where are we? So we are told that it's a positive first derivative and a negative second derivative. When it has a positive first derivative, the function is increasing. When it has a negative second derivative, that's what you got to start with, automatically. And draw yourself a sketch, please. So I drew a mental sketch. Now, why did I rule out C, D, and E? Look at choices C, D, and E. What are they all doing?
Increasing,
No, C, D, and E are all decreasing, guys.
Oh, yeah, you're right.
Please, everybody, look at C, D, and E. You gotta look at f of x, not an x.
This never happened again.
Look here. Look at these three choices here. These three functions are all decreasing. But we were told that it's increasing, so those are gone. So right away I know it's either A or B. But if the graph is concave down, what's happening to my delta x values? They're getting smaller. Think about it this way, watch. Call this 2. Over here, this would be like 3. This here would be like 4. But what's happening is this.
Oh, yeah, that's right.
As I change my x value here, as I go up by 1, if I were to go up by 1 consistently, here's what would happen. Call that 1, call that 2, call that 3, call that 4. What's going to happen here is this. The gap from 1 to 2, the gap from 1 to 2 along the y-axis is 1. That's a gap of 1. But then from 2 of 3, what's this gap going to be?
0.5.
Like 0.5. This gap is going to be even less than 0.5. So what you want to look for are the change in y values that are getting smaller. So look at choice A. You go from 7 to 9. What's the gap there? 2. Then you go from 9 to 12. What's the gap there? So those gaps are getting what? Bigger. But we want the gaps to get? Because we have concave down. If this function had been concave up, then the gaps have to be increasing. Okay, so the gaps, if the gaps increase, it's concave up. Let's write this down. If delta y is increasing, if the gaps are increasing, then it's concave up. Okay? If the gaps of delta y are decreasing now, like we see in choice B, 7 to 11 is 4. Then 11 to 14 is 3. Then 14 to 16 is 2. If the gaps are decreasing, it's concave down, which is what we had in our choice. Okay? Again, the idea is that you're really looking at the derivative of a derivative. That's why the concavity comes. 91. All right. Again, for the third time multiple choice, we're using the net change theorem. It's going to be used over and over again, so we got to get used to it. Let's look at the problem. A particle moves along the x-axis, so the anytime t, its acceleration is given by the following function. A of t equals natural log of 1 plus t, 2 to the t. If the velocity of particle at 2 is given, if the velocity of the particle is 2 at the given time 1, and then find the velocity of the particle at the given time 2. So, what is my relationship between velocity and acceleration? Integral or the other way? Derivative, either one. So, if I go from velocity to acceleration, I'm using a derivative. But here, what does the problem ask me for? It says find the velocity, right? And you're given the acceleration. So you're going to have to integrate the acceleration. And the net change theorem tells me that If I integrate something, I get the original function. Remember, the integral of acceleration is just velocity. So if you integrate the acceleration function from a to b, it's like saying the velocity of b minus the velocity of a, which is also called the fundamental theorem of calculus. That's why the whole thing is called the fundamental theorem. Everything is based on it, really. Okay? Now, if I integrate this from 1 to 2, I have v of 2 minus v of 1. But what was I asked for? What was I asked for? So solve for v of 2. So take this value here and move it over by adding it. So now I have the integral from 1 to 2 plus v of 1. This, how do I calculate this? So use my calculator. You're given a of t, right? A of t was the natural log of 1 plus 2 to the t. I don't want to do that integral by hand. Integrate from 1 to 2 on your calculator. So integrate that value on your calculator right here. And then simply add whatever v of 1 is. But what's v of 1? It was given as 2. Look at the problem. It says v of 1 is 2. Or it says the velocity is 2 when t equals 1. The velocity is 2 when t equals 1. Thus, v of 1 is equal to 2, really. So I replace the v of 1 with the 2.
Oh.
How do we... You sure? We're solving for v2, so get rid of the negative by adding. Okay, that's why we're adding here. There's a plus sign here. Again, we're adding because we moved the v1 over. Now, at this point in time, you integrate. That's what you get from the integral. Add 2 to it. There's your answer. Guys, this theorem comes up over and over again. So we're going to do a lot of problems with it, okay? But the idea you want to remember is this. Here's what you write down in words, please. When you integrate the derivative, you get the original evaluated at the limits. So if I was writing this down, here's what I would write. The integral of the derivative is equal to the original at the limits. Again, the integral in words of the derivative is equal to the original, which might be velocity, position, whatever it is, at the limits. Okay? Again, the integral of the derivative is equal to the original evaluated at the limits. This will come up over and over again. Whenever you're given a problem where you're given, like they say, that g of x is the derivative of f of x, and then they say integrate g of x, you're doing this exactly. Again, if g of x was indicated to be the derivative of f of x, and they say find the integral of g of x, you're really doing the integral of the derivative. That's the net change theorem. So if they ask for this part here, the integral of this would simply be just f of 1 minus f of 2, or whatever these limits are. Okay, this would just be equal to f of b minus f of a. Again, because when I integrate this here, I'm getting back to f. I'm getting back to f. That was number 4, by the way, on your part 2s. Remember number 4 that I was about trouble with?
Yeah.
That was it. This whole thing. That's why I thought we have to go over it for sure. All right.
Water everywhere.
Did they do that though?
What's that?
Did they do that though, like make it another number on the test? Like
What do you
repeat the question?
Oh,
Did
yeah.
it on here?
The fundamental theorem, or the net change theorem that we looked at just now, has come up 3 times as a multiple choice, and it was all number 4. It's used over and over again. That's why I'm making sure we get into it now. We didn't do a lot with it during the year, just because the problems during the year were a little bit easier, right? And the fundamental theorem doesn't come up as much. We discussed it, we definitely showed it, but we didn't go into these kinds of problems. That's what we're doing now. That's why I keep saying to you guys that this is more important than everything we did all year, what we're doing now. Because now we're analyzing these difficult problems. Okay, number 92. It says, let the function be given by the integral from 0 to x of sine of t squared dt for -1 to 3, on which of the following intervals is g decreasing? All right, first of all, this is the statement you have to write down at the top. If g is defined as the integral, then g prime is just the original. Think about it for a second. If you take the derivative of this side here, it becomes g prime, right? But then if you take the derivative of this, what does the derivative in the integral really do? They like cancel out, right? Okay, they like cancel out. But now I have to take this x and plug it in for t, right?
Why?
Because I'm really putting my limits in. I have to do the limits first.
Yeah.
So this, I'm going to have to put the limit in for each of these. So I'm going to have to do sine of x squared. It's really sine of x squared minus sine of 0, isn't it?
Yeah.
But what's the sine of 0?
0.
So you don't have to worry about it. If this had not been x, if this had been x squared, what do I have to multiply by?
2.
1.
2.
Good, but it's 2x. Be careful. If this had been x squared, you would put the x squared in here. This would become x to the 4th. But then remember, you have to multiply by the derivative of that limit, which would be the 2x. And we talked about that last class. Okay? But in this problem, that doesn't happen, so don't worry about that. So now, if g is the integral and g prime is just the original. And this says, find the intervals on which g is decreasing. So I'm interested in g's derivative, right? If I want to know whether g is decreasing or increasing, I want to know about its derivative. So really, I want to know about sine of x squared. So I think to myself, I look at my calculator, I just simply graph this. I notice that there are roots at these 3 locations. Okay, those 3 roots. I see that my graph for this function, it actually looks like this. It has something above the axis for a while, then it comes down and it touches. Oops. This graph is going to be above the axis. It's going to come down, touch at 0. It's going to come back up, come back down, and cross again, and cross again.
You want me to just grab it?
Yeah, I should just graph it. Cross again here at 1.72. Then it's going to be below the axis. Then it's going to be back above the axis. This will be the graph of. This will be the graph of g prime. Okay, again, that's the graph of sine of x squared right there. So what you're going to notice is this. The derivative is only, or the function is only decreasing when the derivative is what? The function is decreasing when the derivative is negative. When is this derivative actually negative? Right in there, right? Which is right in here, between 1.772, 2.507. Choice D.
Can the calculator do like, can you take the derivative of the integral calculator? Like graph it?
I've never tried it. So you do n deriv, parentheses, f int, parentheses, y1, comma x, comma lower limit, comma upper limit, close. Problem with that is that when we've done integrals of derivatives of integrals, hasn't there always been a variable up here? We can't use limits of variables on the T84 then. Only numerical values can go there. Try it, see what, mess around with it real quick, see what you get, okay? I'm sure you'll end up getting a numerical answer. Okay, you'll just get a numerical answer, because you have to give numerical limits there. So it probably won't help you much.
Is there a new calculator that you can do x and x?
Yeah, but it's not allowed on the exam anyway, so nobody will be able to do it. You're not losing out at all. Yeah, you're not allowed the 89 or the titanium or the Inspire that has that capability. You got to use like 84. The exam proctor will. Well, they're gonna walk around and simply go like this, honestly. Okay, T84, you're good. They have a list of acceptable calculators.
I need a Sharpie to put 81.
All right, let's take a look at part 2s now. So flip over, please. Go to this next section with the first region there. And this was 2005, the second form. By the way, every year they do 2 sets of part 2s in case somebody missed the exam. That's what they do it for makeups. There are makeups, actually. I know, right? Makeups. There's no makeups here, so don't miss it.
Dang.
It's only if your school offers makeups. We don't, because we only have 3 exams. Unless you're deathly ill, you tell me ahead of time.
How are we going to tell you ahead of time?
Like the night before, obviously.
It'll be definitely
So these are all the rubrics and all the answer keys for all the free response for all the years. They're all available on College Board. What I can do is maybe post all these files somewhere and send you guys a link to it in case you want to look. So these are all the solutions, the rubrics, And then I have all the actual free responses here from 89 all the way to 2011. So these are where, like tonight, you're going to work on. You're going to work on 2008 free response. That's what your homework's going to be tonight. So that just comes from right here, 2008. So if you want to do more studying and you want to see this stuff, I will post a link to it so you can get an idea.
And then you're gonna delete that link later?
No, this is you're allowed to post this. Part 2s are available to the public on College Board's website. You can go to College Board and find all these. The multiple choices, what's not allowed, which we don't have, obviously. Oh no, we did Form B. I did Form B for you guys. All right, so let's take a look at our solutions. I'm going to go through all the solutions for you, obviously.
No. Yeah, I do. But he said not to use it because it's bad.
Yeah.
But it's okay.
If you need it, you can use it. It's a last resort, though.
I saw that on the news.
I mean, like, it is true, guys. It really is true about this stuff. Make sure you're using normal soap and water when you're in the bathroom.
She had that.
Did it used to play softball?
No, my sister.
Your sister. Oh, sorry. All right, I'll let it slide. I'll let it slide. All right.
Man.
Now, here's what I'm going to do. These first 3 problems are calculator involved. The exam does not show how to use the calculator. So I'm going to go through all this stuff, okay? So first, we're given a function, 1 plus sine of 2x, and e to the x squared, or e to the x over 2. And you can see all the points, by the way, so if you want to see how I graded you, this is how I use the rubric right here. So for example, if you got the wrong limits in the integral, if you did not put the right limits here, you didn't get that point in the beginning. If you had the wrong integrand, any part of it's wrong, you automatically don't get that point. If you had the wrong answer, you don't get the point. Okay? Now, just so you guys know, you do not need this line. That line is not needed at all. Are we clear? Don't waste your time. If you know this is upper, this is lower, upper minus lower, that's all you're going to do then. You do not need that line. They're just putting it there to show. Are we clear on that? Again, the integrand is simply this. That's the integrand right there. You don't need the rest of that stuff. You could just do it in your calculator. Okay, if it's squared and stuff, then we have to discuss how that works.
But, if you don't do the integrand, you do the other part, we just don't have that part.
Start over and talk slower and talk louder.
If you don't write the integrand, you write just the equation, and you still count it as the integrand.
How could you write an equation without an integrand? What would you
Like
write?
instead of writing F and G, I mean,
If you just wrote the second line instead of the first one?
Yes.
Oh, that's fine. Absolutely. Guys, one or the other. You need one or the other there. You don't need them both. Absolutely. Sorry, I didn't understand what you said. All right, so let's go ahead and do this. Let's graph, please. I'm going to graph 1 plus sine of 2x.
You get 1 plus because intersect too, right?
Using the intersection and applying it. The intersection doesn't really give you a point. If you find the intersection and then use that as your limit, that's when you get the point.
Okay.
Finding the intersection alone doesn't do anything for you. It's putting it on the limit that makes it correct. Christian,
Cross out units.
cross out what?
Units. The area, like, when I found the area,
Okay,
I thought it was like.
that's all right. That's a good question also. Unless you're given a problem where it says inches or centimeters or gallons per minute, unless you're given units, you do not need to provide units. Okay? Again, Edgar, did you hear what I just said? Unless you're I know you're helping here, but unless you're giving units, you do not need to provide units at all. So he put units squared, right? Because it was area? I crossed it off for you guys. It's right. It's not going to be marked wrong. But you don't need it. So don't put it, just to be safe. Unless you're given units, don't provide units. Upper function was 1 plus sine of 2x. Second function was e to the x over 2. Everybody see that so far? Now, the AP exam was very nice to you. Why were they nice to you? I know, it doesn't seem like they were.
they give you.
They give you the actual graph, guys. I mean, why do I have all these open?
Oh,
Apparently my limits were wrong.
Really?
Look at this, guys. They give it to you. And how do you know which is which graph?
They gave you an arrow.
They also give you an arrow.
Yeah, they do.
So really here, you didn't have to do any of this work. You didn't have to write anything down. All you did was write this down and find that intersection so you knew what your limits were. So your intersection here is what?
0.
0. 0, 0, whatever that is, which, do I care?
No.
No, I do not care at all. By the way, it's 1, right? Because you plug a 0 in. There's just 1. So this is 0, 1. This intersection, when solved for, let's go ahead and do it. So I go to my graph. I hit zoom 6 at first, right? And look what happens, guys, when I hit zoom 6. That doesn't look very pretty, right? They want us to do it for the first intersection. So we're looking at this piece right here. This is where they showed you. That's it. So what do I have to do?
0 to 2.
Good. Go from 0 to 2 along my x-axis. And on the y-axis, go from 0 to 3 maybe? It's 1, 2, 3 here. So I want to go 0 to 2 on the x and 0 to 3 on the y. So let's do that. Window, 0, comma, 2. Y-axis, 0, comma, 3. Graph. And now it looks like just what they had. Okay? What are we interested in? What region?
Inner region.
R.
Good. Region R, or the overlap of the two graphs. We're not interested in that. Find the intersection here. It's clearly going to be not 1, but what? 1 point something. You know what a lot of students do? They assume that that's 1. But you guys know better. This intersection is going to be a non-integer value. Okay? So go ahead and find it. We press second calculate. I hit number 5 to bring on my intersect. First curve, I go over. It's close to it. Hit enter. Second curve, it's close to it. Third curve, or guess, it's close to it. There's your value. What do I do with that value, everybody?
Store.
Store it. How do I store? What do I press next?
Second
Good. This is my answer right here. So I have to press second quit, press store, alpha A, enter. There we go. We stored it. So on your exam, what you need to write down is the definition of A. Because you can't just say I stored it in A. You got to actually do what they did here. And here's what they did. They said here was the intersection. You don't need to do both of those. You might need the upper limit. It might be possible later. If you're going to revolve the volume around the y-axis, you would need this other limit here. Okay? You're going to need to know how high. If I was revolving this graph like this, I'm doing dy. So I need to know what those values are when I integrate. I would go from 1 to 1.76446. But I don't need that for part 1. So what I would write is this. Let A equal, I'd write the word intersection probably, but let A equal the intersection, which equals 1.13569. So then you could say I'm integrating from 0 to A. Don't use S. They use S there and T. You're going to be storing in A. Use A. You know what A is, okay? Doesn't matter. It's a dummy variable. So you show that integral, you get your answer. So how do I do this integral now? Plug it in the calculator. What's the easy way to do it, Christian? Good. Why am I going to use f of n here and not the graph itself? I'm going to have to do upper function minus lower, right? This, if I were to integrate, if I tried to integrate something like this, it's going to integrate only one of this, not both of them. So I can't use the graph of this. So I go to my home screen, I press math, I go up, or just press the number 9. I want to do upper minus lower. Which one was the upper function again? Sorry, which one? The sine function? So y1, right? y1 is the upper? That's the sine. G of x was y2, that was the lower. So go ahead and type in vars over to y vars function y1 minus vars y vars function, not parametric, sorry, y2, whoops. That's my integrand. Are we clear on that?
Comma X, comma.
We're going to talk about that in a second. Hold on. You cannot write this on your test. You have to use the integral sign with the real limits. You can never write FINT. You can only do it on your calculator. Are we clear on that? You got to actually write an integral sign. Next, comma,
X.
comma, lower limit,
A.
0, upper limit,
A.
A. Close parentheses, enter. 0.429, exactly what they said. Okay? 0.429. And notice, guys, notice the answer, 429 here, 4291. If I didn't store it and I rounded to like, I don't know, 1.13, this would not have been correct. You would end up getting like 0.35 or something, and you're actually getting it wrong. And I'm not joking about that at all. Again, you need to store it. You need to keep at least 6 decimal spots when you're storing. That's why when I wrote it earlier, and when the exam writes it, oh, they write 5, sorry. they give you 5 decimal spots there. If you had rounded this to 1.14, which is what it does round to, it wouldn't be the same answer. You're going to end up getting a little bit of error. It might be like 0.430, something like that, which would be marked as incorrect, actually. Okay? I don't know what you're talking about. I missed it. All right, part B. Find the volume of the solid generated when R is revolved around the x-axis. Isn't that what you think about?
No.
What's your inner radius, Christian? From here to where?
To the first limit.
Very good. To g of x. Carrie, what's my second or outer radius going to be? Oops. Sorry. Inner radius is here. What's the outer radius going to be? So, easy problem here, guys. Very easy problem. Outer radius squared minus inner radius squared integrated with a pi in front. Look at the solution here. So here's what I would do, and they don't do it this way, but I would do it this way. They just, well, actually, I'm sorry, they do. I apologize. They do. I would not do that. I would do just that. Again, one or the other, remember? Just simply write it easier. F of x was the outer radius, g of x was the inner radius. It's always outer radius squared minus inner radius squared. What are my limits again? 0 to a. Why do I put a pi in front?
Area.
Yeah, you're doing the area of the circle and you're extruding it. The area of the circle and you're extruding it. So that's with a pi. Whenever it's a revolution, put a pi in front. Remember that, people. Whenever it's a revolution, a pi is going to be in front. Now, notice here, what do? The exact value, I'm pretty sure, is 4.266 repeating. I think it comes out to be. So in case people rounded to 7, that's why they did that, by the way. You see what I'm saying? That's the reason. Look at the points here. Everybody notice. If you don't have it in this form right here, if you don't have it in that form, look what happens. 0 to 2 points automatically. Again, if you don't have it in that point, you get 0 automatically. It's got to be in the right form. Okay? The answer gives you the last point. If you made an error with maybe the limits, you lose a point for each error. See how it's being graded? But do you see what I'm saying, guys? If you have something wrong in the beginning, you're pretty much screwed. You can't do the rest. That's why a lot of you guys, you might have had some work there, but it couldn't give you any points because you made a mistake somewhere, which caused everything else to be completely wrong. Double jeopardy does come into play, unfortunately, in this test. Okay? All right, the last part. The region R is the base of a solid. For this solid, the cross sections perpendicular to the y-axis are semicircles. So, here's what I've got. A bunch of semicircles coming out of the page. Okay, that's the solid that's coming out. They're all semicircles coming out of the page. What is the volume, or in this case, sorry, what is the area of one circle?
Or
The area of a circle.
Pi r squared.
Thank you. I'm thinking too much. The area of one circle is pi r squared. But I have semicircles, right? So what is it going to be? Area of a semicircle.
Yeah.
Good. Now, what did they tell you the diameter was? The diameter is extending from f of x to g of x, right? So it's just simply f of x minus g of x. That's the diameter. So what's the radius now? Well done. So, when you integrate now, take a look at the solution now. You're going to be doing, you're going to do pi times the radius squared. Here's your pi. This whole thing is your radius squared over 2, because it's a semicircle, times whatever the height of that volume is, which is called what again? Extrusion, very good. What do we call that when we move left to right? Delta x. And when I integrate, that delta x becomes dx. What are my limits again? 0 to a.
You can put a 1.5 on the outside.
I would, Carrie, I absolutely agree. You know what I did when I made the solution? I have my own for this. This 2 moved out front. I actually made this over 4, really. So I moved the 1/8 out front. I would write it this way, and you don't have to. Again, you can write it like this. Okay? Same thing. Again, I'm sorry, what a pi. Sorry, pi over 8. So again, the pi over 2 comes out in front. This is really a 4 in the bottom because it's squared. So I make, instead of a 2, I make that an 8. That's what I would have put. But it's the same exact answer. Okay? So again, the integrand here now, they don't even give you points for anything else besides the integrand here. Same thing here. Integrand's worth everything. And then the answer is worth the other part. Questions on this? All right. I'm going to go on to the second one in a minute, but I want to show you where I got this from so you guys can all see that's available online. So if you go to collegeboard.org, and this, I'm recording this so you can go back and look to see this, obviously. If I go to collegeboard.org, look on the top, hit AP. The reason I'm showing this is because there's even more to it. Then you go to AP courses and exams, because we're looking at the exams. We want to go to exam questions. We want to go to calculus, not BC, but AB, the first level. There's a second level of calculus in high school. Then we go down, and we see, here's all of your free responses. From 2011, all the way down to 2003. Then they have a bunch that are stored from 99 to 2002 there. So, we are currently doing 2005 Form B. 2005 Form B. Not only do they have all the questions, they have the scoring guidelines and some commentary and some sample responses. So you can see, when you hit sample responses, what people that wrote that got it correct actually said. So let's take a look. This is what somebody wrote. Point of intersection. They wrote it down. They actually wrote the point of intersection. Then they wrote the area of R is there from the intersection. I would not write that. I would write A. See what I'm saying? I would do better than this person did here. Then, I really agree with that though, guys. Make sure you make it easy on yourself. Then they got the area of that region as 0.429. Then for part B, the person, here's part B, I gotta go down. For part B, volume is pi, radius outer minus radius inner. They use capital R and lowercase r. It's the same thing as R outer and R inner. Then they wrote the functions in and got the answer. And part C is down here. Here's part C, what they did. They said the radius is f of x minus g of x over 2, which is what Jocelyn told us. We're told that the integral of anything is 1/2 pi r squared because they're semicircles. So that's each section. Then you multiply that by dx. You don't need all that extra work. Just do what I told you guys to do. But you see the sample solutions here. In addition to that, you not only sample solutions, but scoring commentary. So, come on, it doesn't zoom on here. There we go. All right. So, overview. This problem presents a situation. Oh, number 2. Hold on. We'll get to that in a second. The student is given. If I can get there. The student is given a region bounded by the graphs of the two curves that intersect the y-axis and at a second point need to be determined. The student must find the area of the first region, the volume of the second, the volume of the solid region. Then they start to talk about a score of 9 means they got everything right. A score of 6. Traditionally, the student earned the limit points and 2 points for part A, 1 point B, 2 points in C. So they discuss some things about the problem. Sometimes they go into more detail, and now that one was not very useful, but this one is useful. Because they talk about this problem with water being pumped in, and they talk about how it works. So if you're interested in reading about this, I encourage you guys to go in and do this stuff. Okay, I'm not going to have all these things here. They talk about the fundamental theorem of calculus. Okay, so read these commentaries. It will help you. Again, where is that available? At collegeboard.org. Good? All right, let's go to number 2 here. Number 2 is my favorite of all of them. Okay, why was this my favorite? Because I like this stuff that's applicable. Okay, I like to see that we can actually use this stuff. Applicable. So, and water, I think it's actually pronounced both ways. More along.
The first word.
In water tank at Camp Newton. By the way, Camp Newton, it was funny. When I went on a retreat in college, it was called Camp Newton. That was not what I thought it was. Holds 1,200 gallons of water initially. Okay? Why do I know that it's 1,200 gallons initially? Time equals 0. So we're starting with 1,200 gallons. So this is what I'm picturing in my head. We've got a water tank filled up. During the time interval 0 to 18 hours, the water is being pumped into the tank at a certain rate in gallons per hour. Notice units? Everybody see the units? So if they ask you how much water is there, what are the units going to be? Gallons. If they say what rate the unit's going to be?
Gallons per hour.
Gallons per hour. Good. That's the rate of the rate.
That's still a rate. You said rate. You said-
What is the rate at which the rate is changing? Gallons per hour squared. Okay? Be careful. During that time interval, water is removed from the tank. Okay? So imagine, this is realistic. You got a tank of water somewhere. We're pumping water into homes. This is a camp where you're pumping water into a bunch of homes in the district. You need to fill that tank back up, right? So water is coming in and water is going out. If the water coming in is more than the water going out, what's going to happen to the tank over time? It's going to start to increase, right? So the function would be an increasing function then, and it would overfill. If the water is draining faster than the water is coming in, it's going to start to what? So the function is decreasing or goes down. Very good, decreasing function. So here's what I want you to start by writing on the side. If W of t is greater than R of t, if W of t is greater than R of t, we have an increasing function.
No.
Again, if the water coming in is more than the water going out, it's an increasing function. So the height of the tank of water will be going up. And what is the other version? Vice versa. If the water going out, or if the water coming in is less than the water going out, so more water is coming out, the function is going to be decreasing, or it's going to be losing water. All right, so first part, is the amount of water in the tank increasing or decreasing at time equals 15? So what do I do with the 15? Plug it in where? Into both, and see what happens. When you plug it into this one, you're going to get some value. They don't even list the values, by the way.
I got one.
Okay, all they do is say, what's the difference between them? If the water going out minus the water coming in minus the water going out is negative, then it's not increasing, means it's decreasing. So you could figure this out, and then just look at them. If you see that this number here, this number happens to be smaller than this number, so the function is decreasing. So is the amount of water in the tank increasing? No. Why or why not? What's your reasoning here? Because, in words, what are you going to say? Good. The tank is losing more water than it's gaining, or the difference between these two is negative. That's what they choose to say. That reason is completely fine what you guys just said, though. If you simply state R of t, the water losing, is more than the water gaining, thus it's decreasing, or thus it's not increasing. Because the problem says, is it increasing? You have to say, no, it is not increasing, or no, it is decreasing, because it's losing more water than it's gaining. Or the difference between those two values is negative. Okay? That's the first part. How many points you get for that? One measly point. Okay? You need the answer and you need a reason. Without that, 0 points. If you just gave the answer, you get nothing here. There's no partial credit for this stuff. Again, if you just give an answer here, you just say it's not increasing. Not going to get anything for it. Okay?
You know how B has 1,310 gallons? If you don't put the gallons, which one of those would be?
The last one. This should say, well actually let's see, I'm sorry. Funny. Usually it says indicate units at the end here. Since it doesn't say indicate units, you actually don't need them on this problem, believe it or not. But I would do it whenever you have units, use units. Whenever you don't have units, don't use units. Make it easy. Because usually this says answer with units, assuming that this said indicate units here. Okay? Alright, let's go to the second part now. Second part is the fundamental theorem of calculus. We know the rate of change, right? We know how much water is coming in and how much water is going out. But I want to know how much water there is. So if I integrate the rate of change, that tells me how much water there is. Because really, here's what I'm doing. I want to know the actual value of the function. So I want to integrate my derivative. That's what I want to do again. But I'm given the derivative. This is the derivative. This is the derivative. Okay, those are both derivatives. So let's look at the problem. So there's my whole number. How many gallons of water in the tank after 18 hours? Well, where do I start at, guys? 0 hours. So what I'm doing here, and please don't look at their solution, because I do not like the way they put it here. So listen to what I'm going to tell you. We want to know the integral from 0 to 18, right, from 0 to 18, of W of t minus R of t. Of W of t minus R of t. Okay, what's my thing going to be at the end? dt, because it's time. Now, where does this plus 1200 come from, guys? initial condition. I would actually put it afterward. I know they put it in the beginning, it's fine. It doesn't matter at all. But I'm just telling you this because I want you to think about it. The amount of water that the tank either gains or loses in this time period from 0 to 18 is represented by the integral of the derivatives. This is the overall derivative, really. The difference between the rate coming in and the rate going out is the overall derivative. So if I integrate the overall derivative, I get the actual amount. It's the net change theorem, also known as the fundamental theorem. The net change. If I know the rate, I know the overall change. So, what does this number turn out to be? If I went from 1200 to 1310, I started with 1200 in the beginning, and after 18 hours, I have 1310. What must this integral have been? 110. Think about it for a second. I started with 1200 gallons. My answer turns out to be 1310 here. So this integral, when you do it on your calculator, what you will do, you will not do this by hand. You will insert this in y1, and you will insert this in y2, and you will say f int of y1 minus y2, comma x, comma 0, comma 18. There's your command that will give you 110. Are we clear on that? If we're not asked, please ask. Again, this y1 is the rate at which water is coming in. y2 is the rate at which water is going out. The difference between them is the overall rate. When I integrate the rate, the difference, from 0 to 18, I get the overall change in water. There's 110 gallons that have overall come into my tank. At some point it could have gone down, it could have come back up, but the overall change is 110. Since I started with 1200, I have 1310. Part C. At what time is the amount of water in the tank an absolute minimum? Before I go to the answer, because I know you're curious. When do I have a minimum? When the derivative is 0. What is the overall derivative, everybody? Oh, derivative. WT is what's coming in, what's going out. That's the derivative right there. Remember I said, this is the derivative of the water coming in, the rate at which it's coming in. This is the rate at which it's coming out. The difference between them is the overall change. So this is the derivative. So what do I set that equal to? 0. Again, I'm trying to find an absolute minimum. So set it equal to 0. And that's what they did. Let's take a look. WT minus R of T is 0. This is the tricky part. This is where absolute and global and local min come into play. So let's discuss. When I set those equal to 0, okay, I actually, in my calculator, what I would do is this. Okay, here's what I would do. I would go to Y1. Well, no, here's what I would do. I'm sorry. Let me rephrase this. Y1 is already W, isn't it? Isn't that what we put in Y1? And we put this in Y2 earlier? So in Y3, what would I write in Y3? To get the overall derivative in Y3. Remember, Y1 we already plugged in W of T. In Y2 we plugged in R of T. The subtraction of these two is the overall derivative. So plug that into Y3. Now, graph Y3 and find the roots of Y3. Because we're setting it equal to 0. So find the roots of Y3. The roots of Y3 are these right here. Now, if those are my roots, I have to test them, but I also need to test my endpoints of my domain. What were the endpoints of the domain? Very good, Christian. We went from 0 to 18 hours. So 0 is already there. So I do have to test 18. And they want an overall minimum. Which of these values is the overall minimum? Where do these numbers come from, everybody?
The hours.
Okay, they're the roots. What is this number, though?
Oh, the S is equation.
Absolute.
The Y.
Oh, the relative.
The Y. 645.
Wait, like, for example, where's 1200 coming from?
The initial.
Initial condition, right? Initial condition is 1200. Where am I getting 525 from now?
The amount you're adding, the amount decreasing, plus the.
Okay, here's what you got to do, and this is where it gets tricky. Look at the units. What are the units here? So that's the original, not the derivative, right? So to get the amount of water at 6.495 time, you have to do 1200 plus, remember, the integral from 0 to 6.495 of Y3. Remember, the integral of the overall derivative, which is what we stored in y3, the integral of the overall derivative is how much water there is. So that means there's 1,200 here. What would this number turn out to be to get me down to 525? Negative 675? Again, if I have 1,200 and this turns out to be negative 675, that's where I get the 525 there. Then if I want to test the next critical point, what do I have to do?
Same thing.
The same thing. Well, what's my upper limit going to change to?
12.
12.975. And notice, doesn't this become more? So this value, when I do up to 12 now, will be 1,200 plus whatever that gives me this, which is 497. So that's the amount of water I gained from 0 to 12.975. And then finally at 18, we already found that value, didn't we? Wasn't it right here? So take that value and plug it in. So which is the absolute minimum amount of water? 525. And it says, does it say find the time? What does it say? It says, at what time t for part C? So your answer is not 525. Your answer is 6.495 seconds. Or, I'm sorry, hours, thank you, hours. And they don't have units there, but it's hours. Okay, this is a tough problem because you have to do a bunch of integrals in a row. Okay? Christian?
You can't look at y3 and find the minimum of y3 with the absolute minimum of y3.
Y3 is y1 minus y2 though. It's the difference of the rate. So y3 is the derivative. The derivative doesn't tell me. I want the original function value, so I need to integrate to get back to that. Another way to do this before we go, let me do part D real quick before I get to that, because part D is the fundamental theorem. For t greater than 18, no water is pumped into the tank, but water continues to be removed at the rate RT. So after 18 hours, we're going to just be removing water. Give me another 1 sec. I know you got to get to lunch. Give me another minute, please. We're only going to be removing RT until the tank becomes empty. Let K be the time which is empty. Write, but do not solve the equation to find K. All right. So at time equals 18, how much water do I have again? 1310. We solved that, right? So you see how part A or part B is going to impact the next part? So now, I've got 1,310 gallons. I want to lose 1,310 gallons, right? Because I want to get to empty. I want to get to empty. So I know that the integral from 18 to K, whatever K is, of my decreasing rate, because now we're no longer gaining water, there's no W anymore, we're only losing water. So since we're losing water, the integral of this needs to be equal to what? 1310. And what sign on it should it be? I'm losing water. Negative 1310. That's your answer for part D. That's it. We want to solve for K here. If you knew the time K, and you knew this, you know that it's going to lose this much water. How much of it? 1,310 units of water, or gallons of water. Okay? So they just simply put that down. Ooh.
Why is it positive?
Okay, I apologize. My bad. Here. This is why. When we did it earlier, remember when we wrote the integral WT minus R of T? I was still thinking of a negative here. That's why this would be negative. When there's two negatives, though, what happens? Positive. So you were right with the positive there, John. Very good. Okay? Tomorrow, we're going to pick up with number 3. See how long these take to go through, guys. Okay, they take a while. Once you get used to them, though, you can do them much quicker than we're seeing here.